The second speaker is Professor Leeat Yariv from Caltech. Her research focuses on the economics of network and group decision making, including jury, committee, and the electoral election. Today, she'll be talking uh, about what makes voter turnout.
All right. Thanks a lot. Thanks for coming. So this is joint work with Marina Agronov, Jakob Goeree, and Julian Romero. And then the motivation for this is that we noticed a bunch of common features of elections or many other collective processes. So first of all, there is some uncertainty over the majority preferred alternatives. That's the first feature. The second one is that there is this uncertainty despite a lot of communication prior to the election. And this communication can be through polls, through the media, through actual conversations, and so on. Now, toss-up elections are rare, and that's another feature that is kind of interesting. So Mulligan and Hunter, for example, looked at over 16,000 congressional elections and over 40,000 state elections, and they noticed that about 1 in 100,000 votes cast in U.S. elections are quote-unquote pivotal, and 1 of 15,000 votes in state elections kind of mattered. Now, the pivotal voter paradigm suggests a very simple cost-benefit prescription for how you should show up to vote. Essentially, the essence of the pivotal voter model says that you turn out if and only if the benefit is bigger than the cost. What's the benefit? The benefit of voting is your probability of actually affecting the outcome of the vote, which is the probability that you're pivotal, times the benefit of affecting the vote, conditional on being pivotal. So this is the main calculus. Now, in view of that, there are a bunch of puzzling behaviors out there. First of all, many vote, despite the probability of pivotality being very low. So for example, in US presidential election, about 50% of the population votes. Second of all, many vote for the perceived landslide winner. So let me give you a bunch of kind of indications for that. The American National Election Study suggests that 70% of those predicting a large win for their favorite candidate actually went out and voted. If you looked at the Target Group Index in Brazil, they suggested that 13% agree with the statement, I always vote for the probable winner in an election. And Heron did some microanalysis of data and showed that Clinton supporters who believed Clinton was more likely to win voted at higher rates. So in view of that, our goal in this project is to use an array of experiments to actually study this cost-benefit analysis that voters go through. And in particular, we want to understand the response to polls, to polling information, and their own beliefs. And we want to understand the welfare effects of polls. And as a bonus, and I hope I'll have some time to tell you about it, we want to see how people actually behave in polls. So when we think about polls, to what extent are people strategic in them? Now, I'm going to report to you a bunch of experimental results. So there's an important question of why should we even care about experiments. There are the standard reasons, which is the lab allows us to control for preference distributions, and it allows us to track behavior in a very detailed manner in response to the preferences that we impose. It also, in this particular context, allows us to elicit the beliefs regarding outcomes, which is very hard to get from field data. And in addition, it's sort of a cheap way to test for the effects of different institutions. So for example, if you're contemplating ruling out polls, this would be a cheap way to try it out and see the effects. Related literature I won't have time to really discuss, but roughly speaking, there are two classes of literature, one that studies situations where there is no real uncertainty about the majority support, and one that studies polls in a variety of ways. The main difference between what we do and this literature, in case you're not entrenched in it, are the following. So the first thing is that we're going to elicit subjects' beliefs specifically. So this will allow us really to have a test for the pivotal voter paradigm, because that really relies on the perceived probability of being pivotal. And that's very hard to get from field data. We can also inspect behavior in polls and the response to its results, which hasn't been done before. Usually people just assume that individuals are truthful in the polling stage. And we're going to introduce uncertainty over the majority preferred alternative. And this, we think, is a particular situation where voting might matter. If you know what is the majority preferred alternative, in fact, you don't really need an election. You can just choose the majority preferred alternative, and that's going to be the efficient outcome. Okay, so this is what I'm going to do to you. I'm going to start with a theoretical setup. It's going to be a simple, if not simplistic, model of what we're doing, and it's going to serve as our experimental design as well. So it will just allow me to give you a theoretical benchmark of what we're doing. Then I'll tell you a bit about the experimental design. We'll talk about the results, and then we'll have lunch. All right, so here's the theoretical background. So this is going to be the slide of the model. And this is inspired by a nice paper by Goeree and Goeree from 2007. So think about a group of n individuals. And now the preferences are going to be determined as follows. Now, I know it's late in the conference, and this is a lot to digest. So I'll repeat this as I go along. This is not the last time you see it. So nature selects one of two equally likely states, 0 or 1. And you can think about 0 as a blue jar and as of 1 as a red jar. Now, in state 0, the blue jar, the probability of drawing a blue ball is going to be P. So the probability of having a preference that is blue is going to be P, and the probability of having a preference which is red is going to be 1 minus P. In the state 1, the reverse holds. So the probability of drawing a red ball or having a preference for red is P, and for B is 1, it's 1 minus P. Okay, so in some sense, P captures here also the correlation between individuals' preferences, as you'll see. So if the color chosen collectively equals your own color, you get a prize of $V. And if the color chosen collectively does not coincide with your own color, you get $0. Okay, so let me repeat it. It's as if we select one jar, a red jar or a blue jar, then we go across all the individuals, and each one takes a sample with replacement of one ball from the jar. And if you get a blue ball, then you prefer blue. If you get a red ball, you prefer red. Okay? So in some sense, the jar corresponds to the likely majority, and the parameter P captures how correlated our preferences are. Okay? The information that we're going to consider here is a situation where you have no poles and a situation where you have perfect poles. And in a minute, I'll actually introduce even an extra one of actual poles. So in the no poles, individuals only know their own preferences. They know their own colors, but not the state. In the perfect pole situation, you know precisely the jar that had been selected. Okay, so you know whether the red jar or the blue jar had been selected. Now, voting is a simple majority voting. So it's going to cost a fixed value of C, and participants can vote for either blue or red, and simple majority determines the election. If there is a tie, it's broken randomly. Okay? Does this make sense, the model? You'll suffer if this doesn't make sense. All right. Okay, so let me just give you the theoretical benchmark for this very simple model. So first of all, no poles. So we're going to focus on symmetric Bayesian Nash equilibrium. So if you participate, you may as well vote for your preferred color. There's no sense for you to pay the cost of voting and vote against your preferred color. Now, ties are broken randomly. This means that the benefit from voting when you're pivotal is precisely V over 2. Because if there are equal numbers that are already voting out there, this means that with probability 1/2, because ties are broken randomly, you're going to get the value of V. Now, so in expectation, you get V over 2 if you abstain. If you vote, then you're going to shift it to a sure victory, which will give you V. So that's why the marginal difference is V over 2. All right, so proposition 1 says the following. You don't need to focus on the equations, but here's what it says. If the cost is prohibitively high, no one is going to vote. If the cost is very, very low, think about a cost that's close to 0, everyone votes. If the cost is intermediate, it turns out there is a unique equilibrium that equates the probability of voting, the value of voting with the cost. So everyone is going to mix between voting and not voting. Okay? And this just gives you this equation. So this is just a fancy way to capture the probability that you're pivotal. This is the value that you get when you're pivotal and you're voting, and this is the cost. And this probability satisfies kind of reasonable comparative statics. So it's going to be decreasing in the cost of voting. It's going to be decreasing in the correlation of preferences because it's sort of a free riding sort of situation. And the more people there are, the less likely you are to be pivotal, and you're going to vote less. Okay, perfect polls. So we're going to focus on quasi-symmetric Bayesian Nash equilibria. So this just corresponds to saying that if everyone who gets the red ball, who sees red and gets the red ball, is going to vote in the same way. Okay, and likewise for all the other combinations. So proposition 2 says that there's a unique quasi-symmetric Bayesian Nash equilibrium where the majority voters participate with lower probabilities than the minority voters. So now you know whether you're the likely majority or the likely minority. When you're the likely minority, in order to win, to have a shot at winning, you need to participate more. So that's what happens in equilibrium. And in fact, elections are likely to be toss-up elections. That is, they're likely to be very, very close elections. Again, the reason is that everyone is going through the same cost-benefit analysis. So everyone is equating their marginal benefit with the marginal cost, which is C, the same for everyone. So therefore, we should expect kind of a very close election because everyone in equilibrium is experiencing the same marginal benefit. So polls reduce total welfare because they do two evil things. The first one is that they stimulate the minority to participate, and that's costly. So more people are participating, and that's costly. The second thing is that the majority preferences is less likely to actually get its preferred alternative chosen. Because we're likely to get these toss-up elections, we're less likely to get the efficient outcome. So in that sense, polls are actually very bad from this perspective for welfare. How about real polls? We actually know very little about real polls. So in real polls, individuals who know their own preferences are free to report whatever they want, whether they'll vote, whether they'll abstain, and what they'll vote for simultaneously, and then the aggregate statistics are dispelled. So in the perfect polls, I just told everyone what is the realized jar. When you think about polls in reality, people actually report what their preferences is, and then they get some aggregate statistics of these reports. So we might want to understand to what extent do these reports that may be strategic reflect the underlying distribution. Now, it's very hard to analyze this model, and I won't have time to give you the details, but if we focus on symmetric pure strategies at the polling stage, that is, people don't randomize between the reports at the polling stage, then essentially, without loss of generality, we can focus on two types of equilibria. One that is babbling, and for those of you who've worked on communication models, this is always an additional equilibrium. So we always have equilibria in which people just don't say anything useful. And then we're back to the characterization of the no polls situation, and ones that are fully revealing. Now, like I said, the babbling is always part of an equilibrium, and then participation rates would be given by proposition 1 that I showed you that correspond to no polls. Fully revealing equilibria, that's a bit tricky. So for those of you who know the Palfrey-Rosenthal model, that's a situation where you know precisely how many are in the majority and how many are in the minority. So that's basically what happens here if people reveal truthfully what they'll do. So you know precisely what will happen in the next stage, effectively. What is the size of the group? So these games may entail equilibria, but for our parameters, it turns out that there is no such equilibrium that is consistent with this. What is roughly the intuition? If you don't know the Palfrey-Rosenthal, don't worry. Essentially, if everything is revealed perfectly, we know that the minority group is going to be likely to participate more. They have more. They need to participate more if they have any chance of winning. So this means that you always have an incentive to make it look as if your group is in the minority in order to induce more participation. So you have an incentive to lie about your own preferences. Okay? And this is why this is intuitively not going to be consistent with this equilibrium. So to summarize kind of the theory benchmark, the pivotal voter model, and that's really the essence that you should get out of this, suggests that voters respond to the likelihood that their vote would matter. And the implications are that the turnout is higher when the probability of a close election is higher. Information regarding the distribution of preferences in the population, for example, through polls, induces the minority to participate more, and therefore polls decrease welfare, because overall participation goes up, and that entails a cost, and the majority preferred alternative wins less frequently. Okay? So these are really the two things that you should carry out. Polls are kind of bad. More information is bad for welfare, and people should respond to the likelihood of being pivotal. All right, so let's go to the experimental design. What I'll do is I'll give you an overview of the sessions that we ran, and then I'll talk very briefly through the experimental instructions so you get another view of the model as well as have a sense of what our subjects actually saw in the lab. So here's what we did. We had 3 treatments, no polls, perfect polls, and lab polls, just as the ones I just described theoretically. We ran it with groups of size 9. And now our probability P was 2/3. So in the lab, we actually showed them 2 jars, a blue jar and a red jar, where the blue jar had 2 blue balls and 1 red ball, and the red jar had 2 red balls and 1 blue ball. So in the blue jar, if you sample 1 ball, the probability that it's blue is going to be 2/3. That's how it was modeled. The prize from matching the group choice with your own color was $2. Now, in addition, we also asked subjects to predict the group composition, how many preferred blue and how many preferred red, and we asked subjects also to predict the vote outcomes. So how many will vote for red and how many will vote for blue. All the sessions were run at the California Social Science Experimental Lab at UCLA, may it rest in peace, and with 198 subjects. All right, so now I'm going to talk very fast because I'm essentially going to repeat information, and stop me if I'm being unclear. So here are excerpts from the instructions. This is what subjects would see when they came into the lab, and although I would talk slower. The experiment consists of 20 periods. In each period of the experiment, you will be part of a randomly selected group of 9 subjects. In each period, the computer will pick one of 2 jars, both being equally likely for your group. The red jar contains 2 red balls and 1 blue ball. The blue jar contains 2 blue balls and 1 red ball. You will not know which jar was chosen for your group. So this is the no polls treatment. In each period, we will randomly draw a ball with replacement from the selected jar for each of you. The draw's color is your type. We actually did this physically in the lab, so this sounds very techy, but we actually did this to explain it to them. You will not know the types of other members of your group, and others will not know your type. All you know is that others' type are drawn from the same jar as yours. Each person in your group will have the option of voting for one of the 2 colors or abstaining. That is, each of you will have to choose between the following 3 options: abstain, vote blue, or vote red. You will incur a cost if you vote for blue or red. In 10 periods, the voting cost is 25 points. In 10 periods, the voting cost is 50 points. So this is important. I didn't spell it out before. There were 10 periods in which everyone had the same cost of 25, and 10 periods consecutive that everyone had the cost of 50. We also switched the order just to make sure there are no order effects, but I won't talk much about it today. The voting cost will be indicated on your screen and is the same for all members of your group. To summarize, after observing your type and your cost, you will have to choose between abstain, which is free, blue, which is costly, or red, which is costly. The color receiving the majority of votes will constitute the group's choice. In case of a tie, we will randomly pick the red or blue color as the group's choice, both colors being equally likely. So your earnings will depend on your group's choice, your type, and your voting cost. And here's the payoff matrix that corresponds to your payoffs. So this just describes what I described before. If the group decision coincides with your own type, you get 200 points. Each point was 1 cent. So this is this $2 prize, or the V in the model. If the group choice doesn't coincide, which are these 2 rows, with your own preferences, you get 0. Prior to making your actual choice between abstain, blue, and red, you will be asked to guess the composition of your group, the number of reds, the number of blues, summing up to 9, and the number of red and blue votes in your group, including your own, possibly summing up to less than 9. At the end of the experiment, we'll randomly pick one of your guesses. If it is correct, we'll give you a $10 bonus. This was designed so that they wouldn't have an incentive to actually ignore the game altogether and just aim at getting this guess correctly. And there are quite a few indications that, in fact, they didn't do this, but I won't talk about it. But so I hope you'll have faith. When each member of your group has made a selection or chose to abstain, the group's choice is calculated. You will see the selection made in your group and your resulting payoff. So again, just to summarize, this is the end of the excerpts. The treatments were the following: 3 information treatments, no polls, where subjects know only their own type, whether they prefer blue or red. Perfect polls, where subjects know their type and the state, the jar. And lab polls, where subjects first learn their type, then they declare their intended actions. This is the actual poll. And the resulting overall statistics are displayed. So the number of intended blue and red votes, they might not sum up to 9. And then subjects choose whether to vote and to whom or abstain. Okay. And 2 cost treatments, 10 periods with low voting costs of 25 points and 10 periods with high voting costs of 50 points or cents. All right, so let's go to the results. So I'm going to do this in 3 steps. So I'm going to describe to you, first of all, the aggregate outcomes. So this is just the overall effects of polls and information and what we saw. And then we'll go into the voting behavior, which will suggest to us the fit of the pivotal voter model in particular in this setting. And hopefully I'll have some time to discuss the poll reports. All right, so some robustness notes on how I'll describe the results. There were no order effects in terms of the cost, so the results are going to be aggregated across these. There is little learning, so I'm going to show you results from all the periods aggregated. So if it were a longer talk, I would give you more details on this, and we can check whether there's learning or not, which is sort of interesting in these settings. All right, so first of all, recall that the theory suggests that when you give people more information in the form of polls, you should expect toss-up elections. You should expect much closer elections. So this is the cumulative distribution function of the lead of the elected candidate. And what you see here is that in fact the polls do not lead to more toss-up elections. So polls actually generate fewer toss-up elections and more landslide elections, so more elections that are further away in terms of the lead. And perfect polls and lab polls generate very similar distributions. Yeah, in fact, the sessions are nicely ordered in terms of first-order stochastic dominance here. In terms of welfare, you can think about 2 types of welfare criteria here. First of all, you can think about the likelihood of actually electing the majority preferred alternative. And the second one is just utilitarian welfare for the group. Okay. Let me show you a big and daunting table. So you can focus just on the last 2 columns. These just correspond to different types of compositions of types. So this is just if you're curious. But first of all, if we look at the top rubric here, and we look at the majority preferred, the likelihood of selecting the majority preferred alternative, what you see here is that polls in fact help. Okay, so when we look at polls, they help somewhat in selecting the majority preferred alternative. The overall costs actually look very similar. They're statistically indistinguishable. So recall that the theory suggests that polls, more information, would induce more participation, thereby increasing the expenses of voting. This is not what we see here. And as a consequence, when you look at the net welfare, it looks, if anything, a little bit better when we provide subjects with information, either through perfect polls or through the real polls. So information leads to better outcomes, particularly for close elections. This information does not raise cost, which is contrary to theory. Information does not reduce welfare, which is contrary to theory. And with respect to cost, the comparative statics work very nicely. So more costs leads to less participation, etc. All right, I'll skip that. All right, so let's try to dig into these results to understand what in the behavior is driving this inconsistency with the theoretical predictions on the aggregate outcomes. So first of all, here are the overall participation rates. So what you see here is for the three treatments, what we know from the theory and what we observe. So for the two costs. So there are several things to notice here. First of all, the minorities participate less than the majority. So this, so recall that when there was some information out there, we should expect the minority to participate more. This is not what we see here. Polls increase the majority participation but reduce the minority participation. And perfect and lab polls yield similar results. Okay? With respect to cost, everything looks good. So with the comparative statics with respect to cost is the one thing that is kind of in a persistent manner follows what we should expect from the theory. Subjects respond to these incentives. All right, so what I'd really like to focus on now is understanding their voting behavior. So we're going to use the elicited beliefs to understand the participation rates. And recall that the underlying message of the pivotal voter model is that the more likely you think the election is close, the more you should participate. Now, if we just divide it in this way, we look at perceived closed elections or perceived landslide elections, we see what we would expect from the pivotal voter model. So perceived close elections generate more participation than others. And so with the perfect polls, it's 0.59 and 0.49. So 0.59 when you think that the election is going to be very close, and 0.49 when you think the election is going to be a landslide election. With lab polls, these numbers are 0.62 and 0.43. So looking at that, this would seem like the pivotal voter model is doing fairly well. However, there are two types of elections that are not close. There are those where the preferred alternative is winning by a large margin, and there are those where the preferred alternative is losing by a large margin. So let me give you the graphs that correspond to the participation rates as a function of the perceived lead of the preferred alternative. So what you see on the x-axis is the perceived lead of the preferred alternative. So 0 corresponds to being pivotal. And what you see here are increasing curves. There's it seems like sometimes there's a little spike around 0, but in general, these are increasing curves. The pivotal voter model would suggest something that looks like a hump-shaped curve, where we have a peak at 0. Here we see something that looks kind of monotonically increasing. So this are increasing curves which are inconsistent with the pivotal voter model. And in fact, if you just, this is just a different way to look at the same question. If you divide it into the expectation of a big loss, where you have a loss which is greater than 1, a close election, where you think that you're either tying with the other alternative or different by 1, or a big win, which is a greater than 1 difference in favor of what you're doing, what you see here is that there is much less participation when a big loss is expected. Okay? So participation rates are significantly lower when a big loss is expected, and they're not significantly different across close elections and those with expected landslide victories. All right. Now, you might worry that, in fact, what's driving this is not so much how they respond to their beliefs, but rather that their beliefs are somehow screwed up. So it might be that they just have very screwy beliefs, and then they somehow correct for that in their behavior. So what I'm showing you here is the mean guess lead of the preferred alternative as the function of the actual lead. Okay? So for any actual lead, I'm drawing here the mean guess of the lead. So if they had perfect beliefs, we would expect to see the 45-degree line. What we see here is something which is not perfectly the 45-degree line, especially with no polls. So no polls is a situation where they don't know anything but their own preferences, so it would be a miracle if they could predict the actual lead. But for the other two treatments, they're actually fairly close to the line, so they don't have completely screwed up beliefs here. All right, I'll skip the regression analysis, and I'll give you some results on the polls before concluding. So first of all, how do subjects behave in polls? This is something that's very hard to get at data. You don't know what are the actual preferences of people, so it's very hard to know whether people are truthful or not in polls. So polls overestimate voter turnout. 82% report that they will vote, whereas the overall turnout is lower than 50%. And of those that report that they will vote, about 42% end up participating. And this has been observed. So the suggestion that people overreport their participation has been observed using, at least in the U.S., using this American National Election Study that tracks people over time. Subjects rarely vote for an alternative different than that declared. So there's not much strategic polling in the sense of lying about what you'll vote for. And polls reflect the ultimate election outcome. So despite this mismatch between the participation and the declared participation, if you just looked at the polls, you would actually do a fairly good job at predicting the outcomes of these elections. So they predicted correctly about 84% of our elections. How about outcomes? Now, in this literature, there are two types of phenomena that people discuss. One is the bandwagon effect, and the other is the underdog effect, and they say exactly the opposite of one another. So the bandwagon effect says that the predicted winner gains additional support after the poll publication, and the underdog effect is the opposite, which is that the predicted loser gains additional support after poll publication. Now, in the political science literature, there's a consensus that both of the things exist. And there is a long-standing debate as to which one is the dominant effect. So there's a meta-study that was done fairly recently by Irwin and Van Holstein that suggested that bandwagon is more prevalent than the underdog, at least since the 1980s. But there's not really we don't still have a great understanding of when we should expect one as opposed to the other. Now, if we look at our data, if we look at the actual lead as a function of the predicted lead by the lab polls. Okay, so when we ran the lab polls, I'm just looking at the actual lead in the election as a function of the predicted lead when we look at the actual polls. What we see is this graph. So notice that on the left, we actually see the bandwagon effect because the actual lead is above the actual lead, the predicted lead. Whereas when we look to the right, we see the underdog effect. So effectively, the bandwagon effects are observed when poll victories are small, and the underdog effects are observed when poll victories are large. All right, so to conclude, what I showed you is an array of experiments that inspect voters' turnout response to beliefs and information that is transmitted by polls. In terms of outcomes, polls actually don't reduce welfare, and they yield more landslide elections. So this is in contrast to kind of the concerns by the theory that a very basic model would suggest. And what we see is that bandwagon effects depend on the margins of victory, essentially. So whether we should see bandwagon effects or underdog effects depends on the margins of victory in the polls. In terms of the rational voter paradigm, what we see is that the propensities to vote increase with the vote lead. So this is kind of in contrast to the underlying premise of the rational voter paradigm. But if you just look at close elections as opposed to landslide elections, things look pretty good. So people do respond to closeness to some extent. In terms of the polls overestimate turnout, and they accurately predict election outcomes. And this is sort of useful because we didn't know this, and I think there might be something interesting and theoretically as well, because we usually assume that people are, we just assume people are truthful in the polls. And that's all, folks.
Um, Thank you very much. We still have time for people question for either of our speakers. Um,
Is your preferred theory then in the end some kind of norm for voting?
You're asking me. We actually don't think it's much of a norm. Who knows? But we looked at different models. So maybe you're suggesting kind of an ethical voting type of
Yeah,
model.
I vote,
Yeah.
personally, I vote because I think it's a duty.
Yeah, but then it's weird that people respond to the lead. They don't just vote as a rule of thumb. They do respond to leads. They just respond to them in a strange way. So the model that we found that fit the best, but this is not shocking, is a model that is kind of voting with the winner. It's almost like when I watch soccer, I always support the winning team. I'm a big fan for Argentina today. But now the fact that I showed you that people vote with the winner, and then I fit a model that says that people vote with the winner is not, a great exercise. What is interesting is that when you fit such a model, you actually get very similar distributions of individual parameters of how much you care about going with the winner across our treatments and across sessions. So this model exhibits some consistency across all our treatments, but I don't know. If I were designing an experiment for that per se, I would maybe design it a bit differently.
So, can you explain again why, not to Alex, so can you explain again why the sort of it was sort of reasonable to guess that the equilibrium will be that x was very near, I think the support was x bar in the case, so that, because there it was very clear to see why the two effects, the, the, that you're being solicited more often exactly cancel. Yeah, but I thought that if I understood correctly, that's because the support was very close to it, so that's why you could kind of get the two. I think I forgot the notation. I thought it was x bar, no? The x star and x star was the right.
for Leeat. I'm not sure whether I'm right, but it seems that in the theory experiment you assume that the payoff matter to the voter only so far as whether they are in the majority, right? So if I'm a majority, I get 200. If I'm not in the majority, I get 0. So people actually have other preference than you say in the. Yeah, but if that's the case, it's probably not really like a real community where people have real preference, direct preference over the other alternative. But that's an easy question. But also has implications on your interpretation because theory said the more likely you've been the pivotal voter, more likely you're going to vote. But in your experiment, it's not really like this because the more disparity you have of the winner and loser, the more sure I mean will be in the majority. So, but if I'm in majority, I get 200. So it becomes more likely that I'll vote if the game is designed this way.